So, you check, make sure that the day for June is no greater than 30, right? Or less than 1. And so that's checking to see whether you have valid data or not. So you can perform various tests. You can check the range, like I was talking about. Its reasonableness, that's kind of nebulous. To see if it's a valid menu choice to avoid dividing by 0. Valid menu choice, didn't we do that sphere density? Did we do the sphere density problem?
Yeah, it's a homework.
Yeah, I mean, we set it up in the last lecture, right? Thursday. Okay, so, we can check to make sure they made a valid menu choice. Now, that was pretty easy. All we did is we put a final else statement down at the bottom. But we could have checked it right off the bat. We could have made sure that what they chose was a good menu choice, right? So as soon as we got our choice, if it was an int, for example, we could do if choice is less than 1, or whatever our minimum value is, or choice is greater than, whatever the max value is, then tell them they didn't make a good choice. Now, sticking that in the else statement at the bottom of the sequence of else's is just a fine way of doing that. But that is a form of data validation. So, test score validation. Validate the input and determine the grade. The first thing they do is check to see, is the grade greater than minimum score and the test score is less than or equal to the max score? That means it's a valid score, and they go ahead and calculate it. You made an A or a B or a C or a D or an F. But if it doesn't fall between that range, and notice they used an AND because they're checking within a range. That's how you check to see within a range. Good, got it going. If it's outside of that range, we tell them invalid score was entered. Run the program again. Another important form of data validation would be to make sure that they didn't just type in absolute garbage. If we want a number, but they type in letters, probably going to crash our program, and we should know how to fix that. Yet we don't know how to fix that yet. Comparing characters and strings. If you're going to compare two numbers, you know that 1 is less than 2. So if x is 1 and y is 2, then x is less than y. But what about letters? Well, A comes before B in the alphabet. So if you say x is equal to quote A and y is equal to quote B, then x is still less than y because quote A is less than quote B. What's the mechanism it uses to determine that? It uses the ASCII value. So if I go to ASCIItable.com.
So the char data type is a single
What?
byte.
Go away.
Or if you need to use Unicode in order to
Please stop.
type in Russian
Who's talking to me?
then you'd have to compile it in such a way that they would be a double byte.
Where is?
But it's still the same idea. So every character can hold one and only one.
Right there, right there, okay. Edge, looks like. Alrighty, okay. So, back to where we were, ASCIItable.com. We see that A has a ordinal value of 65, and a B has an ordinal value of 66. So if it's comparing the two, it's going to say that the A is less than the B. That gives us some oddities. What happens if you compare a lowercase b to an uppercase A? Which one's less? The uppercase A is lower than the lowercase b. That's not alphabetical order, right? Well, I mean, it sort of is. But if you have a uppercase B and a lowercase a, you might think according to alphabetical order, this one's greater than that. But it's really less than that. And so all the lowercase letters, since they appear at the end of this, are greater in value than their uppercase variants. So you can try to take that into account by converting all the input data into uppercase before you start doing your comparisons. Or you can do something a little bit more complicated than that, which I'm not going to cover. I wonder if they cover it. I doubt it. So lowercase letters do have a higher ASCII code than uppercase letters, so lowercase a is greater than uppercase z, which is not intuitive. All the lowercase letters have higher ASCII values than any uppercase letter. So here we're just comparing to C relational operators. and ASCII values. If this character is greater than a 0 and less than a 9, we've entered a digit. Else, if the character is greater than or equal to a capital A and less than a lowercase z, then we entered an uppercase letter. Else, you've entered a lowercase letter. Else, that is not a digit or a number. Now, if we go back to ASCIItable.com, we see that there's two places that punctuation is hidden. Punctuation, not including a space, is 32 all the way up to 47, but then for some reason they tack some more on at the end. 123, 124, 125. So if we wanted to check to see if something was punctuation, we'd have to check two ranges, not just one. So if we had a character, well, let's grab our boilerplate first. I seem to remember an input function that got a single character from input called getCH. Let's play with that for a minute. CH equals getCH parentheses CIN. Close parentheses semicolon. Do I have the syntax right? Probably not. Let's look up getCH. And it's not even in that chapter. All right. Here I'm trying to get fancy, and I just don't remember how to use it. getCH C++. Come on, don't be slow. So we have several functions that do that. getC, getChar, getCH, and getCAG. getC reads a single character from a given input stream. Great. getCH is a non-standard function. I am not seeing what I'm doing, and I'm wasting our time by looking for it. I could probably just go and look at the last PowerPoint, and it would spot out. CIN.getCH. So what's the difference between .get and .getCH that are part of the CIN IO streams? Well, while it's sitting there taking forever to load, let's just give it a shot. CIN.getCH. So I'm going to write a message that says type a key or press a key, enter a key, and then CH is equal to CIN.getCH, and it's not there. Forget it. Then why in the world was it listed? I'm going to throw a fit. Nope. All right. We're getting rid of that. It's not working. Don't feel like it. We're just going to make it a character ourselves, right? And so we're going to check to see whether it's in an uppercase range or a lowercase range. So uppercase A starts at 65 and goes 32 past that. So we could do this. If the character is greater than or equal to 65 and less than, and the character is less than 65 plus 32. Now where'd those numbers come from? I should do it the way that they did it. Let me go look in ASCIItable.com and get the real numbers. 65 is an A, a lowercase z, uppercase z is 90. So let's make it greater than or equal to 65, less than or equal to 90. That'll make it an uppercase A. And we just need to put something to that effect. C out, uppercase, backslash in quote, semicolon. Elif, excuse me, that's Python, else if ch is greater than or equal to, where does the lowercase letters start at? They start at 61. Excuse me, 97. 97 and ch is less than or equal to, and I believe it's 125, but I better go check. 122, I was off considerably. Then it's lowercase. So greater than or equal to 97 and less than or equal to 122, C out, lowercase. Else we're going to get to the weird set, which are the punctuation, which are strewn all over the place. If we go and look at ASCIItable.com, punctuation goes from 32 up to 46 or 47, and it goes from 58 to 63 to 64, and it goes from 91 to 96. So that's an annoying number of things to check for. And then lastly, there's space. Well, a space is exactly one thing, so let's check for a space. That was easy. Else if ch equals 32. You know what, we don't need these braces. I'm going to get rid of these braces because fit more stuff on the screen. Quote space, end quote, semicolon, or backslash n, put a backslash n in there. Else if parentheses ch is greater than or equal to 32, ampersand, ampersand, ch is less than or equal to 64, because that's the range above space but below uppercase A. I misspelled else. Then C out punctuation. But there's 3 ranges of punctuation. I could check for them all at once. It would be a pretty long if statement. It would say if ch greater than whatever and less than whatever, or ch greater than something and less than something, or ch greater than something less than something, and we'd have to put parentheses to force the ands to happen before the ors, whatever. So why don't we just use several of them?
Is that one including space?
That is including space, so you're right. We should make that either greater than 32 or greater than or equal 33. So I just made that correction. Thank you for catching that. So else if ch is greater than or equal to, what's the highest letter in uppercase? What is its ASCII value? Z has an ASCII value of 90, so anything from 91 to 96, just a short little range. So ch greater than or equal to 91, ampersand, ampersand, ch less than or equal 96, C out, less than, punctuation, backslash n, end quote, semicolon. And then there's one small little batch of punctuation at 123 and 124 and 125, I believe. Let's go eyeball those. After lowercase z, 123, 124, 125, and 126. So else if ch greater than or equal to 123 and ch less than or equal to 126, it's still punctuation. \n, end quote, semicolon. And if it's none of the above, it's some kind of control character. Else, cout less than unrecognized character. It's either not a standard ASCII character, or it's down there, you know, in the control codes below 32. I really wanted that input to work. I'm going to get insistent on it. I'm going to scroll back up here, and I'm going to do a cout, enter a character, and press enter, colon, space, end quote, semicolon, and then just CIN greater than CH. Let's just see if that works. I thought if we were reading in a single character, we had to do something special, and I think I'm wrong about that. Otherwise, we can read it into a string and get the first character if that's what we have to do. But anyways, for example, a Y. That is uppercase. I'll scroll back down to the code in a minute. I just want to thoroughly test it. What is a period? A period's uppercase. Okay. What is a Y? Lowercase y. That's uppercase. Something going on here. Let's print out the value of CH and find out what it is. So cout less than int parentheses ch end parentheses less than endl. Let's just find the ASCII value of what they just typed. And maybe it's always A. Maybe this is just failing right here. We'll find out. So lowercase y. Yeah, this is not working. It's not filling in a single character. That's why we needed to use getChar. Okay, I give up. I'm going to go and look on the last PowerPoint. What I should have done to begin with. I just like showing y'all using Google to encourage you to use it. Okay, it's not in that one. Oh, for Pete's sake. Okay, it's cin.get, not getch. That was my mistake. So we're going to just have to change one line here. We're going to make this one say cin.get parentheses ch in parentheses. You dirty dog, you. Oh, that's because I made it an integer. It should be a character. Wow. Okay, there we go. The other one might have worked just as well. But here we go. Now it's going to work. Lowercase y is a lowercase letter, and its ASCII value is 121. All right. I'm sorry for spacing on that, guys. I made that error on purpose just so you could see me try to fix it. Yeah, right. Okay. So we could write functions that would check to see if something is uppercase or is lowercase. We could write a function called isUpper. Right? It would just need that line of code right there. Does anybody need from here to here? Or do you have typos that you'd like help with?
It's working just fine, but here I'll show you. So I entered in and it's displaying it back. I couldn't find where.
All right. That just, we would want to put before the semicolon there, less than ENDL. Anybody else? Okay. So let's write some functions that check for is upper and is lower and is punctuation. Now I'll give you a sneak preview. I know I need that line right there. That first one mentioning 65 and 90, so I'm just going to copy that before I go and write my functions. So it needs to return true or false, and that's called a bool. And this one's going to be called is upper. Or actually, don't I usually use lower cases and underscores? I'll do that. So bool is upper, parentheses, and it needs to take a character. So char space ch in parentheses, open curly brace, and just paste what you copied. If ch greater than equals 65 and ch less than equal 90, return true. And if that's not true, we're going to return false. Now we could shorten that into a single statement, but I'm not going to do it on that line, but we'll do it on is lower, just so you can kind of compare and contrast. So copy that function and paste it and call the copy of it is lower. And is lower just takes a different range, right? 97 to 122. Let's see if my short-term memory can keep that going. 97 to 122. Copy all this. Paste it. I said copy, paste, call it is lower. And just change this a little bit. First make that 97 and that 122. But then just put the word return there and a semicolon there and delete the rest of the returns. You see what this is doing? This is performing this evaluation and immediately returning the results. And since this evaluation will return or will calculate out to either true or false, that's what gets returned. Here we're using an if statement, but the if statement is superfluous because if this is true, return true, we could have just returned the result of that expression in the first place. Hope that kind of makes sense. Either way is totally fine to write this function. The more experienced programmer will write it that way. All right. Is space is incredibly easy, right? Because all it does is check to see if it's equal to 32. So copy whichever one of these you like, whichever format you like better, and paste it and call it is space and check to see if its value is 32. So this one's called is space, and it's a space if the ASCII value is exactly equal to 32. Now it's the last one that's got a whole bunch of different ways of being punctuation. So honestly, it would be faster if we just copied all of that stuff, right? From that if 33 to 64, all the way down to that if 23 to 126. Just copy those 6 lines, and then let's go up and make a new function called isPunct. Sounds like an MTV show. Bool. Anybody ever, do they still make that? Good old Ashton Kutcher punking people. Is punct. Parentheses, char ch in parentheses. Paste what we copied, but we have to make a few changes. For one thing, I forgot my curly brace. And don't make it start with else if. The first one should be if, and instead of outing something, it should return true. And the same for the second line, return true. And the same for the third cout, that should just return true. And one final dangling else to hold to, if none of the other cases are true, return false.
So if you have multiple conditions, you have to force it to return true?
Well, we could rewrite this. Let me show you how you could rewrite this. And you might agree that it looks ugly. We could, like, have an open parentheses there, and then we could check all that and then have an or here, and then check all that and have an or here, check all that and have an or here, and then one final, right, close parentheses. There we go, right? We're checking within all three of those ranges. There's nothing wrong with writing it like that. And since and has a higher priority, higher precedence than or, we probably wouldn't even have to space it out like that. We could probably just do it like this. I'm just going to add this as a comment. We could probably take all the parentheses out, but that leaves us with a really long expression. So I didn't mind in this particular case breaking it up like that. Does that make sense?
Yeah.
Okay. Okay, so let me get rid of that one. I mean, I guess it's interesting, but no, wait, that's the good one. No, it's not. That's the one using or. I want to get rid of that one. Okay. So we could use one of our functions instead. If, parentheses, is underscore punct, parentheses, ch, in parentheses, cout, you didn't type a letter or number, \n, quote, semicolon, right? Because it's a non-alphanumeric character. But that counts a space as being a character. So that's good enough. Let's just make it say that's punctuation, isn't it? Let's test it out. I'm going to put an equal sign up here, and it says that's punctuation, isn't it? So why would you bother making that functions? Because you might want to use that code over and over and over. That code is awesome enough that we're going to put it in its own file so that we could bring it into other files. So we're going to take all of those functions and all of our boilerplate, just grab all of that stuff from the pound assign define. Now we don't really need all of these. We could probably just get away with doing IO stream and skipping the rest, but we can tidy it up later. Grab from there to there, copy all that stuff. No, tell you what, just copy bool is upper, bool is lower, and bool is space, and bool is punct. Just grab all of that stuff and copy it. We're going to wind up deleting it eventually, but if we cut it right now, then I could accidentally lose it. Copy it, and we're going to come over here, and we're going to add a new source file. I need to come up with a good name for it. Care utils or something like that. CHUtils. So over here, I'm going to add a new CPP file and change its name to CHUtils for character utils. And we're going to paste those functions that we just copied into it. And that's not going to work, is it? Because we don't have the pound sign include in the using statement, but that's easy to add, right? So we have to have pound sign include less than IO stream greater than. I think we have to have that. And then using namespace std. You know, I don't think we need any of that because we're not using streams or strings at all. So we don't even need those two things. Let's get rid of them. Now that I've successfully moved all of those files into my all of those functions into my chutils file, I'm going to go and remove them from my lecture file. So now my lecture file should only have our boilerplate and main up at the top. Well, how's it going to work? How's it going to call isPunct? It needs a prototype. What's a prototype? It's a function definition without a body. like this. Bool is underscore punct, parentheses, char ch, in parentheses, semicolon. This is a prototype. It sets up, it's the header of the function, but without the body. And it's telling the rest of this code how that function is called, what it returns, but the body of it's stored in a different file. And this is a very common thing to do. But that means that anybody who's going to use our character utils has to, well, let's compile it and run it, make sure I haven't broken it yet. Has to go and add that line to their source code in order to use my utilities. And that's kind of lame. The last thing we're going to do with this particular example is we're going to add a header file that has the prototypes for all three functions, or all four functions. So I'm going back to source files, adding a header file, new item, header file, and I'm going to give it the same name as the C++ file, except it's going to end in .h. So CIT1173, I forget whether I called it with an S or not. Yes, I did. And I just need those prototypes. So I'm going to paste all that code, but remove all the bodies of it and just leave the headers. This is what my header file looks like. It just has the definitions of the functions, ending in semicolons. And now once I go back to my lecture code and add # include and include my own header file, I can use any of those functions that I want within main. But they're in their own file. I could give another programmer this file and the CPP file, and they could use my utility functions. Or maybe we put it in some kind of shared directory. So I need to add a # include above my main file to bring in these prototypes. So maybe here, # include less than, or not less than in this case, chutils.h, end quote, semicolon. Notice the difference. Oops, no semicolon on # includes. The double quotes mean that that file is located in this directory. The angles mean that it's going to search a search path for that file, because we don't have a file called cmath in our own source code directory, but we do have a file called chutils.h. Now for those of y'all who were doing this, who were typing the code along until I lost you, I'm going to go ahead and stop it and try to get you set up. If you look at our file structure now, I was slightly careless. I should have dropped the header file over here in the header file directory. It doesn't make any difference because they still wind up all in the same source directory. So we have a CPP, which has got our main code. We have a # include, and it's got double quotes around the header file, our own custom header file that we made. Those double quotes say pull it from our directory, the same directory as our CPP file. If instead you enclose it in angles, then it searches a search path, a code search path for it. And this is not part of Microsoft's library. Instead, it's our specific one, so that's why we put quotes around it. In the same directory, we have our header, excuse me, not our header file. We have our file that's full of our functions. This code over here would not be able to use those functions unless it had access to prototypes of them to tell it how to call them, what kind of arguments it requires between the parentheses, and what it returns. So that's what the header file does, is it defines each function, indicates the number of arguments and what they have to be, in this case a character, and what it returns. And so then the compiler knows how to hook up our calls in main with the code that's stored in the chutils.cpp. And I ought to do a lot of this for y'all. I ought to make you store a lot of stuff in header files, because if you become a professional C programmer, C++ programmer, you will be doing that. Now if you take Java, Java is kinder. You don't have to set up prototypes and you don't have to set up header files. The compiler for Java just searches all the source code files and builds an internal map of them so that you don't have to do that. But you do in C++. C# is like Java in that fashion. You don't have to do that. Python is somewhat similar, because in Python the order of the functions is very important. If you don't have a function defined before you try to call it, it won't work. But in Python there's no such thing as a prototype, so the code gets a little strange where you're trying to move your functions into the right place so that they can be found. Alright, so relational operators. What was all that to do? The reason I took us off in that direction was to illustrate header files and having multi-file projects. That was the point of that. The other thing that was just to reinforce the idea of using AND to check within a range. And I'm not going to demonstrate it here, but you can use OR to check outside of a range. I suppose we could add that to our code if we wanted to. We could add one more function called isInvalid, right? And if something is outside of our good range, if it's below 32 or greater than 126, then it's invalid. So we may as well do that. Let's just get our stuff complete here. Bool is invalid, takes a character, and we're going to check outside the range of valid ASCII characters, which is 32 up to 126. So if if CH is less than 32 or CH greater than 126, it's invalid. So we're going to return true. Else we're going to return false. And we should add this as a prototype to our header file. Each time we add something to our utility CPP file, we need to add it to the header file as well, or else main would not be able to call it. So now that I've written that up, I'm just going to copy the function header, paste it in, and add a semicolon. Make it a prototype. Grab that, go to my header file, tack that on, and there we go. So we could check to see what they typed in. Now I can't think of too many ways of typing in an invalid character, but I could use the numeric keypad to do so. So let's add a call to isInvalid in here, right? So maybe right here. If, parentheses, is underscore invalid, parentheses CH, in parentheses, cout, lesson, not a valid ASCII character. Let's close this. Can't see everything here with it in here. \n, semicolon. Right? And then make that one say else if, right? So how am I going to get my invalid character to test it? I think I told y'all this, but if you have the numeric keypad enabled, if you hold the Alt key down and type in some numbers, it'll let you enter Unicode characters past the regular 127 character set. So I'm going to take advantage of that. When I run it, I'm going to hold the Alt key in and type in 127, and there's my non-ASCII character. It looks like some little Monopoly house shape, and it says it's not a valid ASCII character. So on that function we used OR to check outside the range, right? If it was less than 32 or greater than 126. The rest of these we were checking within a range. If it's greater than 33 and less than 64, and so on. And the conditional operator. I thought we talked about this already. Is this looking familiar, gang? Well, we'll do an example of it one more time. If we have a number, for example, and we want to check to see if it's even or odd, let's do this. So in my main, maybe up here at the top, just because it's easy to spot, I'm going to make a number, and I'm going to set it equal to 327 or something like that. And then I'm going to create a string call it type, semicolon, and then type is equal to, and I'm going to use a conditional operator, so that means that there's going to be a question mark in it and a colon in it. That's also known as a ternary operator because it's got 3 parts instead of all the other binary operators requiring 2. So if type modulus 2 equals 0, that means it's an even number. If we divide it by 2 and get 0, it's an even number. So after the question mark, put the word even, and after the colon, put the word odd, end quote, semicolon. Oh, that was supposed to be num, right? If num divisible, excuse me, if num modulus 2. So I don't know why I typed the word type there 2 times in a row. And then we could print that out. Cout less than num less than quote is end quote less than type less than ENDL. And it's going to say whether that number is even or odd. And it better say it's odd. Right? So let's run it. And it was in fact odd. Good. Let's change it to even to check it the other way. So I'm going to make it 326. Run it. And there we go. Right, 326 is even. When I write these, I like to make it a little bit clearer what's going on by putting these things in parentheses, like that. No, the whole thing in parentheses, not just that first part. Everything in front of the question mark. So the way you read this is, if this is true, then that is the result, else that is the result. It would be just like wording it like this. If that is true, then type is equal to that, else type is equal to odd. Those two things do the exact same thing, but this does it in 1 line, and that did it in 4. So that's the conditional operator, the question mark followed by the colon later on. Ternary operator requires 3 things. The first expression evaluates the true and false. If it's true, it returns the second one. If it's false, it returns the third one. I know we talked about switch statements. The expression for a switch has to be an integer variable. It can't be a string in this language. In Java and C# it can be. But it can't be floating point, because floating point errors would mean that the comparisons might not be precise enough to get it to work. The break statement causes a switch to exit, but break is also used in while loops and for loops. So if we had something like this, int count equals 0, semicolon, while count is less than or equal to 100, print out count, so cout count, and then add 1 to count. But for some reason, we really wanted to stop at 50. If count is equal to 50, then break. It's going to exit the loop early. It's not going to get all the way up to 100, because once it hits 50, it's going to break. And so it did. There's a similar keyword called continue. What does continue do? Well, break causes it to jump to the closing brace, and then it does whatever's after the closing brace. Continue causes it to immediately reiterate the loop. Checks it again without doing anything else. So if I do this, if count equals 10, or let's do 45, so it'll be at the end of the input. Continue, semicolon, and then we couted our answer. So I'm moving my cout to the bottom of the body there. When I run it, it counts from 0 to 99, but it exits at 50 because of that break. But notice it skipped 45. It went from 43, 44, 46, 47, 48. Why did it do that? because 45 was for some reason a special value. And when it hit 45, it did a continue, which caused it to jump back up to here. And so it skipped the printing of the number. So that's what break does. It's used in several different contexts. One is to exit a switch statement. We don't have a switch statement in here, but we used one in the last assignment, in the last lecture. And it's used to exit loops early. You could do that to do data validation, to ask them for a number, and the number has to be between 1 and 10. And if they type in a bad number, then we're going to yell at them. So let's declare a number, a variable called number, and we're going to do while parentheses true. The book doesn't show this tactic. The Python book does, for which I am impressed, because most textbooks don't show while true loops. So while true is an infinite loop, right? It would keep doing this forever. If I printed something, it's just going to print hello forever. So I am going to need a break statement in there somehow to get it to get out of there. See, there's all my infinite hellos. Don't want that. Stop. Okay, there we go. So let's ask them for a number. Cout, enter a number between 1 and 10. Colon, space, end quote, semicolon. CIN, greater than, number. Now let's see if it's a good number. If, parentheses, number is less than 1, or number greater than 10, it's bad data. So we're going to tell them that. Cout less than, end quote, bad data, bad. There we go. Else, it's good data and we can break. So else break. And it'll leave the loop. So this is going to loop until they type in a number between 1 and 10. Or we could have worded it like this. We could have used an and checked within a range. So if number is greater than or equal to 1 and the number is less than or equal to 10, it's good data. And we can just break right there. Else we print out our error message. Cout less than, bad data. Either way works, right? You could put your break as part of the else, or you can just make your break part of that. I like that way better, actually. It's up to you. So now when I run it, it's going to force me to enter good data. I can still probably wreck it by typing in a letter rather than a number, but if I type in 11, that's bad data. Negative 123, that's bad data. How about hello? Yeah, it goes nuts. All right. Not too good. We still haven't learned how to fix that. What we would want to do is to clear the input buffer. We'd want to yell at them, tell it was bad data, clear the input buffer, and then let them type it in again. And I've just about forgotten how to do that. If the PowerPoint shows us, we will. Oh, let's take a shot at it. CIN.ignore. Make it like 1,000 characters. You know, hello was only 5 characters, so it would only need to ignore 5 characters, but I'm just going to say, okay, ignore all the way to the end of the line or 1,000 characters, whichever one you reach first. So, hello, and that didn't work, so forget it. I'm not going to keep working on fixing that. Get lost. Okay. When we hit the slide in the PowerPoint that shows us how to do it, I'll point it out. Oopsie. So that's what a break does. Causes an early exit. It's mandatory in the switch statement for the switch to work correctly. Like this. Here they use fall through. They're very sneaky. And the reason they're able to use fall through is because they're saying that a Model 300 TV has picture-in-picture and stereo sound and a remote control. But a Model 200 only has stereo sound and a remote control. And a Model 100 does not have picture-in-picture or stereo sound, so it just has remote control. So they're not using break for these two cases, so it does fall through. If they enter a 300, then it prints that, but since there's no break, it goes ahead and executes the next one as well and prints out stereo sound. and it executes the next one as well, prints that out. So on that telephone digit program where we were entering a letter and having it get converted into a number, you can do something like this: case A, and then case lowercase a, and then case B, and then case lowercase b. Something is bugging me. In our code example last time, were we doing a switch on a string after I just told you you couldn't? Let's go look. Well, that's totally wrong. Why don't I just... That's why we save all the notes. Has anybody started working on the homework yet? Did we not have a telephone assignment where we were checking to see a letter typed in versus...
I don't remember.
Yeah.
Had something.
To be honest, I don't remember switch at all.
Last homework we had was the triangle checker?
Was it?
No, it was the gold ball density thing.
That never made it to the module though.
Well, that would be one of the reasons why I'm confused. And I guess the telephone checker was a Java assignment, but I didn't think it was. Y'all really aren't remembering switch at all?
No.
Okay then. Well then. Alright, so the homework assignment for the density apparently did not get its own folder created. I will fix that. Here's what a switch does. Here's what a switch does. I need to go back to main in the correct file. Oh, this is nagging at me. Oh, it was for the online Java 1 course. Okay. So say you had some value, like a score. And your score could range, well, we just asked them for a number between 1 and 10, so let's use that. A 10 is an A. A 10 or a 9 is an A. An 8 is a B. A 7 is a C. And your professor's a jerk and doesn't allow D's, and so anything else is an F. We could write that with if statements. We're pretty good with if statements. If number equals 10 or number equals 9, then C out less than A, right? Backslash n, end quote, semicolon. Else if the number is 8, it's a B. So else if parentheses number equals 8, C out less than B, backslash n, end quote, semicolon. I'm going to copy that and make that say else if it's a 7, it's a C. And if none of those are true, then they made an F. That's pretty standard. We understand that logic. A switch is another way of implementing that. What you do is you have the switch keyword, and in parentheses you put the variable that the switch is based on. And just like a switch can have, like you might have a heater that has, you know, low, medium, high, this has discrete discrete results. So switch on the number in case 10, in case 9, in either one of those cases, it's an A. So C out less than quote A, end quote, backslash N, semicolon, and then break. We're going to do the same thing for 8 and 7 and 6. Well, 8 and 7, and then give them an F if they as a default. So case 8, that's a B. C out less than B, backslash N. End quote, semicolon, break. I'm just going to copy that and paste that so I can make that say 7 is a C. And if none of those are true, just like this dangling else here that fixes that one, now I'm going to pad these out correctly. So you see the setup is about the same. 10 and 9 is an A, 8's a B, 7's a C, anything else is an F. 10 and 9 is an A, 8's a B, 7 is a C. The default case, if none of the others are true, is an F. And you can put the word break, but in that case it's not necessary. So these two do the exact same thing. If I enter a 10, it's going to print an A from here, and it's also going to print an A from here. I'm going to put question marks on this one just to make sure that they look different than these, right? And exclamation marks on the ones done with a switch.
You're missing
Did I goof something? Pardon?
missing a semicolon after break.
Yeah, you're right. Thank you. There we go. So now when we run it, enter a letter, yeah, whatever. Enter a number between 1 and 10. I made a 10, so I want to see an A. Yep. Both of those structures work, both the if and the switch. Now this one actually looks longer, doesn't it? Well, but it's in a way it's more structured. Why do I say that? I don't know. But you know, if you had a whole bunch of choices that could add up to an A, then you could just list them as additional cases here. Like, although it doesn't allow 11s because of our loop up here, you know, we could throw that up there anyways. What happens if you leave a break out? What is that break keyword for? Here I was expecting you to have already known, and that's why I kind of glossed over it with that while loop. If I enter an 8 now, it's going to print B, but since there's no break, it's not going to exit the loop. It's also going to print C. And it printed B and C. So the switch statement's got more flexibility in a way than a series of if-else-ifs, because if you feel like making it execute multiple cases, you can. You just leave off the break statement. It's about time to end this, but I do want us to see this. On Tuesday, we're going to come back and we're going to do something again with switch and case, and it's going to set up the next homework assignment. If we left out all the break statements, then if they typed in 10, it would print A, and then it would run down here, and since there was no break to stop it, it would print out B, and then it would print out C. So I'm going to undo those changes. Let's make a Dropbox, and we'll be done, and since, yeah, let's just end that as we'll be done here.